Hello everyone, welcome back to Educquiz. So we are on for the second exercise on the topic of matrices. So the exercise goes by find the value of a constant k for which the matrix A is singular, where A is this. B says find the inverse of the matrix B, hence solve the system of equations this. So it's quite similar. This B part is quite similar to the A part which is before. Then on the okay, so now we did not find the image of the point, so we are going to see what the image of the point looks like. So let's start on with A. A says find the value of the constant k for which the matrix is A is a singular matrix. Okay, let's copy the matrix A. You have A where A is 2, 3, 4, 1, minus 1, 2, 3. Is that 3? 5. Okay. 5, 0, k. It looks like 3 from a. Okay, so we should find the value of k for which this metric is a singular matrix. You first have to know what is a singular matrix. Determinant is 0. It's either a singular matrix or a non-invertible matrix. It does not have any inverse because the determinant is 0. So we should find the value of k for which this matrix will be singular. So we should find the value of k for which the determinant of this matrix will be 0. So let's assume there is a value k. Let's just try to find the determinant of this. So the determinant of A is going plus into cancel this and this. We have minus k plus 0 times anything 0. Then we have minus 3 for the second. Cancel here and we cancel here. We have 1 times k is k minus 10. 2 times 5, 10. Then plus 4 into 5 times minus 1 minus 5, which is the same like plus 5 finally. Minus 5 is the same like plus 5. So let's simplify. We have the magnitude of A, which is 0 actually, is minus 2k minus 3k plus 30 plus 20. So we have magnitude of A is equal to minus 5k plus 50 actually. But we know that the magnitude of A is 0 since it is singular or non-invertible. The magnitude of A is 0. That's what was told. So it implies minus 5k plus 50 is equal to 0. So I have to find k. This implies minus 5k is equal to minus 50. When this 50 crosses, it becomes negative. You have a minus 50, which implies k is equal on minus 5. Because you divide all through by minus 5, you have minus 50 divided by minus 5. Which implies k is equal to this cancel this, we have 10. So this was quite easy. I think we had the value of k as 10. Then we can go to the B part. The B part says find the inverse of the matrix B, hence solve the system of equations. When they ask you to find the inverse of the matrix B and say hence solve the system of equations, it means you have to use the answer here to solve the system of equations. So when they say hence solve the system of equations, it means you have to use this inverse. If you use Cramer's rule, your answer will be correct, but do not follow the rules, the instructions. Do not use the hence, then you'll be wrong. That's an error that I used to do. I did once, and I really argued with my teacher. I mean, the answers are correct. I used matrices. But he said no, you had to follow the hands. He said you should use this to solve. So you are using the inverse method. So B, you have to find the inverse. So the inverse of matrix B, what's matrix B? That is it there. I don't really want to copy it back. So B inverse will be equals to 1 all over B magnitude, the determinant of B, times the cofactor transpose of B. Or you can replace this by adjugate or adjoint. You write it like this. You can write it like this at the place of cofactor transpose of B. You write like this is correct. So let's first find real quick the magnitude of the determinant of B. So B magnitude is going to be, you have 2. You have 2, 3, 4. Well, let's copy B back. B is equal to 2, 3, 4, 2, 1, minus 1, 2, 5, 0, 2. Here is B. So the determinant of B is 2 into, this is plus minus plus 2 into, you cancel here and cancel here, you have minus 2. 0 times anything is 0, so you don't consider it. Then minus 3 into, you cancel here and here, you have 2 minus 5 times 2, 10. Plus 4 into, you cancel here and here, you have 1 times 0, 0 minus, you can write 0 minus or just minus 5 times minus 1 minus 5. So this is actually plus 5. 0 minus minus 5 is plus 5. I'll just put the 5 here. So magnitude will be 2 times minus 2 is minus 4. 2 minus 10 is minus 8. Minus 8 times minus 3 you have plus 24 plus 20. Which implies the magnitude of B is going to be 40. I think so if I calculate it well. But yeah. So you part the magnitude. The determinant of matrix B. When we have the determinant, what we have to do next is to find the cofactor. Then you do the transpose. So let's find the cofactor of B. You can cancel this A part because we have solved it successfully already. So to find the cofactor of V, I'll have to find the cofactor of each of them that we've been doing. So I'll start with the cofactor of these two be equal to what is inside here, negative 2. Cofactor of 3 be equal to what is inside here, 2 minus 10 minus 8. But I use the sign. This is plus minus plus. So it's going to be minus of minus 8, which is going to be 8. Because here is minus of times, this minus will be 8. So cofactor of 4 is going to be what is here, positive 55. Then I can start calculating the cofactor of 1. Cofactor of to have minus sign here is minus, this is plus, this is minus, this is plus, minus, plus. So the sign here is minus, so I put my minus sign behind. So what is the cofactor of minus 1? We're going to be cancel here and cancel here. You'll be left with cancel here and cancel here. You'll be left with 2 times 2, 4 minus 20. We have minus 16. So cofactor of 2 is equal to, cancel here and cancel here, 2 times 0, 0 minus 5 times 3 is minus 15. And if the sign here, this is minus, plus, minus. Minus 15 times the minus here becomes plus 15. Actually. So, cof of 5 is equal to, cancel this and this, you have 3 times 2. 6. 6 minus 1 times 4. Minus 4. So it seems like 6 plus 4, which is 10. What is the sign? Positive. So I keep my 10. Minus 1 times 4. 4. 4 minus 4 is 0. No matter. So finally, the cofactor of 2, I'll have, I cancel here and here, 2 times 1. This is minus 1. 2 times minus 1 minus 2. Cofactor being here. What's the cofactor of 5? Cancel here and minus 4. 10. Plus 10. Okay. After 2, you cancel here, you have minus 2 minus 3. That'll be minus 5. Okay, so we have all of our cofactor values. So what is our comatrix? Cofactor. So cof B, we are dealing with matrix. Copy all of your values. You have minus 2, 8, 5, minus 6, minus 16, 15. So here we have the cofactor, then we find the cofactor transpose, which is actually the adjugate or the adjoint. All of the rows become the columns. So row 1 becomes column 1, row 2 becomes column 2, and row 3 becomes column 3. So you have minus 2, 8, 5 will be written down. Minus 2, 8, 5. The second one down is minus 6, minus 16, 15 will be written like this. Minus 6, minus 16, 15. Then you have 10, 0, minus 5 will be written like this. 10, 0, minus 5. And that is our cofactor transpose. So, yeah, when we have the cofactor transpose and we have our determinant as 40, then we can find the inverse. So, how do I find the inverse? I'll have to write this. I'll do 1 all over the factor transpose. I have minus 2 0 5 15 minus 5. So when I do my division, I will have 140. Okay. So when I do my division, I'll have 2 divided by 40 is minus 1 on 20. 6 on 40 is minus 3 on 20. 10 on 40 is 1. 8 on 40 is 1 on 5, I think. Minus 16 on 40. Minus 16 on 40. 40 is the same like. Minus 8 on 20 is the same like. Minus 4 on 10 is the same like. Minus 2 on 5. Minus 2. Then we have 5 on 40. 1 on 8. 15 on 40. 15 on 40 is the same like 3 on 8. 3 on 8. Then 5 on 40. Negative 1 on 8. It'd be more advisable to punch on the calculators to have these answers like this. Because me putting them, I'm not even 100% sure that it's correct. Well, we have, so it's 1 on 20, negative 1 on 20, 6, 2 times 3, 20, 10, 1 on 4, 8, 1 on 5, oh my, 16. We have 8 on 20, we have 4 on 10, we have 2 on 5, minus, okay, 0, 15, we have 3 on 8, not simply Bible. Okay, so we have B inverse to be this. So the B said find the metric B. It says hence solve the system of equations this. Now we have the inverse of the matrix B, which is actually B with this system of equation. Let's just represent it. It is B times X, Y, Z is equal to 1, 2, 5. Hence X, Y, Z is equal to 1, 2, 5. This implies that to find X, Y, and Z, you will do 1, 2, 5 times the inverse of D. If you divide all through by BA, is B to the power X, Y, Z equal to 1, 2, 5 times the inverse. Fortunately, we calculated the inverse. That's the use of the hence. They say use this to find X, Y, and Z to solve the system of equations. So let's just multiply those and go to the next step, to the next part of the question. Find the image of the point. The multiplication. Okay. So let's multiply this. We have X, Y, Z. 1, 2, 5 times V inverse of minus 1 on 20, minus 3 on 20, 1 on 4, 1 on 5, minus 2 on 5, 0, 1 on 8, minus 1 on or even anything more. Beautiful. Okay, yes, beautiful enough. Okay, so 1 to 5, okay? So let's multiply this. Let's multiply it. When you multiply, you see 1 times, you have to multiply this column by each of the rows. So multiply the column by the first row to find x. So x actually is going to be 1 times this, which is just negative 1 on 20, plus this times this, which is minus 3 and 10. You can remove the plus since there's already minus, you put the minus. Then this times this, which is plus 5 and 4. And you invite you to calculate this on your calculator, which is going to give negative 1 on 20 minus 6 on 20 plus 25 on 20. So we have a common denominator. What I did is just, since this is the highest denominator, I made all of these to be the highest denominator. So this is 20. If you multiply both up and down by 2, you have 6 here and 20 down. If you multiply up and down by 5, you have 25 up and 20 down. So since the denominators are now the same, you can just add up the numerators and divide by the common denominator. So 25 minus 6 minus 1, 18. 18 on 20. That will be actually the value of x. So y is going to be 1 times this 1 on 5 plus, since it's original minus, is going to be minus 4 on 5. 1 on 5 minus 4 on 5. They have the same denominator, so it's 1 minus 4 is minus 3. So z is equal to 1 on 8 plus this times this 3 on 4. I simplified already. 2 times 3 is 6. 6 divided by 8 is the same like 3 divided by 4. So minus 5 on 8. So that is equal to, if I multiply this up and down by 2, I'll have 6 here and 8 here. Then I can just add up all of this. So I have 6 plus 1, 7. Or 6 minus 5, 1. 1 plus 1, 2. 2 on 8 is 1 on 4. So you can actually leave your values like this, or you write x, y, z. Nine on 10, minus 3 on 5, 1 on 4. This is it. So for the C part, they say find the image of the point negative 2, 3, 1 under the transformation matrix defined by B. So let's do the C part here. We already did the B part successfully. So let's do the C part. When they ask you to find the image of a point under the transformation matrix, it means you have a matrix B. You have a point. Let's imagine that this is C. The transformation matrix is B. The image will be this C prime. So if you have a point like this could be called the point C. The matrix, which is this, will be called the matrix B. The image, they ask you to find the image. So B is the transformation matrix here. The transformation matrix means a matrix which changes a normal point into its image. B is a mirror which, when I see myself, it shows me my image. So B is that interface, B is that mirror. So when they say find the image of the point this, means they're asking you to find the they're telling you that. So your mirror here is B. Find the image. That when you put the mirror B, it will give you that it will give you that image which is of the point. It will give you the image of the point this. So you had your mirror, you had your point, you should find that image. So all you will do is just to multiply these two, you'll find the image. So C here is negative 2, 3, 1. Negative 2, 3, 1 times 2, 3, and 2 large. 2, 3, 4, 1 minus 1, 2. What is it equal to? Actually, that's the image. So they're just asking you to multiply in different language. So you have, this is one column, these are 3 rows. So we do this column times the first row, this column times the second row, this column times the third row. So what you have is, on the first row, first column, you're going to multiply this by this. You have minus 2 times 2, which is minus 4, plus 3 times 3, 9, plus 1 times 4, 4. The second is minus 2 times 1, minus 2, minus, I put minus because I'm seeing minus here, that's why I put minus, I don't put plus. Here there was no minus, that's why I just put plus. And I see minus, I just replace it. And I just multiply 3 times this. So 3 times 1 is, 3 times minus 1 is minus 3. I've already put minus, so I replace with 3. So 1 times 2 is plus 2. Then finally I have this, minus 2 times 5 is minus 10. 3 times 0 is 0, then plus 1. So the final answer, C prime. C prime is the image of C. C prime is minus 4 plus 4, 0 plus 9, 9. Minus 2 plus 2, 0, minus 3, minus 3. Minus 10 plus 2, minus 8. Can leave your answer like this, where C prime is the image of C. And you're done. So you can see this exercise 2 was just a little bit more complex than exercise 1, but as interesting as exercise 1. So thank you for watching exercise 2, and make sure you follow, if you want a higher difficulty on matrices, make sure you see exercise 3. That is a really tough exercise. So